All right. Let's see what 6.3 is about. Let me write down the title here. 6.3. Trig functions of any angle. All right, so there's some conceptual questions. Find the exact value. Okay. So basically, this is my X and Y points. So I need to find the radius, which is the hypotenuse. Okay. So given a point, so number 5. Eight comma 1.
Mr. Gonzalez,
Yes.
hey, are you able to switch screens? Like the big one is your paper that you're writing. That way.
Yeah, I'm gonna switch in just a moment.
Okay, thank you.
Thanks for reminding me though. I wanted to just write the question down real quick.
Yeah, absolutely.
Okay, so given a point, I'll go ahead and draw it that way. That way you have it. Excuse me. All right, so we want to know sine cosine of this angle. And here is the point, X and Y. So they are not telling us that this is a unit circle. So I cannot assume that the radius is 1. So basically, this means that sine theta is equal to y over r. Cosine is x over r. Tan theta, excuse me, y over x. Cosecant, r over y. Secant, r over x. Cotangent, x over y. So we have x equal to 8, y equal to 1. So r, r squared, I'll put this over here, is equal to x squared plus y squared, which implies that r is equal to the square root of 8 squared plus 1 squared. So square root of, what is that, 65, right? You guys agree with that?
Yes.
All right, so now we just plug it in. Now we got everything. And we're good. So this would be like our little formulas. Same with this guy. So sine is equal to 1 over square root 65, which is square root 65 over 65 when you rationalize. Cosine theta will be equal to 8 over square root 65, which is 8 square root 65 over 65 when you rationalize. Tangent theta will be equal to 1 over 8. Cosecant theta will be equal to square root 65. Secant will equal square root 65 over 8. Cotangent will equal 8. So here are my answers. Do you have any questions on how we arrived at these values? In the algebra or trigonometry? Oh, wait a sec. Oh, excuse me. All right. So part B will be the same. Just keep in mind when you do, for example, when you find sine and cosine, remember I gave you all those signs of where they are positive and negative? You should know that cosine is negative over here, so it's tangent and cotangent. But it should be automatic when you try to use these values, but if you get something that doesn't match up, because it's quadrant 2, so anything with an x in it will be negative, right? So anything, any of the x formulas would end up being negative. It should just happen when you plug it in. But if you notice one is positive, then something's off, right? Anyway.
Can we do that one too as an example?
Part B, is that what you're asking?
Yes. The question you just had up,
Mm-hmm.
the -7, can we have like do that as like as a practice or an example?
Yeah, hold up here. Let me just show you real quick. It's not nothing crazy. It's exactly the same. Nothing changes. I just want you to keep in mind that this part is negative, the x value. Okay, so when you're doing, so you would find the r the same exact way. So r would be equal to the square root of 7 squared plus 7 squared. I don't know what that is. What's 49 times 2? Is that 98?
Yeah.
So then you'll have sine. This may reduce though. 2 goes into 98, or just 4 go in there. Nope. 9. 85. I don't think it does.
You can reduce it to 7 square root of 2, I think, right? This is what my calculator says.
Obviously, right? I'm stupid. Yes, you're right. Because obviously we just said, right, 49 plus 49. So that's 249. That's funny. So this square root is like you said. Square root 2. So sine will simply be the y value over this guy. Yeah, it's the same. When you do the cosine though, I want to make sure you don't forget the negative. Because cosine is negative in this section. So it should be -7 over that over this value. Okay. And then you have to rationalize, and these cancel. So you should start to notice that that's a specific angle, right? It's right in the middle. As you can see, cosine is negative, right? Tangent will be equal to -1. And the rest will be reciprocals. So all you gotta do is find your radius. And plug in your values into the formula, make sure it is rationalized. If you have any issues with rationalizing, let me know. Because I didn't show the step before. Anyways, any questions on this one? That's basically the same setup. So the last one was okay too? Because I didn't show any rationalization. You guys comfortable with that? Okay. I'll move on to something different. Just use these formulas, find R. Oh yeah, sure. Square root 98. So the idea basically, I'll do this on a different page. Square root of 98 is the same as square root of 49 times 2. So you can separate the radicals like this. Square root of 49 is 7. So you purposely look for squared numbers inside. That makes sense? Like, for example, if you had a root 12, you would look for a squared number. So the shorthand is like, well, I know this will be square root of 4, so that'll be 2 root 3. You don't have to keep showing this step. All right. 6 is similar, except they don't draw it out for you. Let's do something different. So here they're testing us. See if we understand the quadrants. They're saying here, what if sine is negative and cosine is negative? Which quadrant would we be in? Where are they both negative?
4.
Close.
3.
It's going to be 3, because so up here we're both positive for x and y. Over here we're negative for x, positive for y. Here they're both negative. Here it's plus minus. So 3. So it's 1, 2, 3, 4. Which we talked about before. I think it was the first day. Remember I gave you the where all the x and y are negative. So remember that sine is all about y. Cosine is all about x. So just remember where is the x and y negative. That'll be the same question. That makes sense for 7?
Yes.
Okay. Number 8. Here they give us, we'll do this one right now. They give us cosine, right? And then they give us a hint and say, well, tangent is negative. Okay. Well, if tangent is negative, that means because tangent is equal to y over x, right? So that means that one of these has to be negative. Either the minus could be on top or the bottom. I don't know. Right? But cosine is positive, so that means the x is positive. So it has to be up here. It doesn't actually matter where you put the minus, but it matters if y or x is positive or negative in order to build a triangle. So basically, you're going to build your triangle. That's a horrible triangle. Just go to the paper. Excuse me. Find the exact values for 6 trig functions. Okay, so this tells us that x is equal to 21. We don't know what y is. We do know that it is negative though. R is equal to 29. Right? So if tangent is, as theta is here, cosine would be 21 over 29. So solve for the missing side. What is that going to be? I don't know if it's a perfect magical triangle or not, but I feel like it might be. Right, so do Pythagorean theorem. Y would be equal to plus or minus the square root. I forgot to put in the R.
Can you move your journal up, please? Thank you.
So that'll be 29 squared minus 21 squared. What is that going to be?
Gives me 20.
Yeah. Is that a perfect triangle after all?
Yeah.
Nice. But since we know y is negative, we will choose the minus. Okay. So when you screw both sides, you got to tack on the plus or minus, but choose minus because of this hint here. If tangent is negative, that means either x or y is negative, because tangent is defined as y over x. Cosine is already positive, so that means only the y is negative. That's why I chose the minus. Is that clear? So once you have that, just plug in all the stuff into your functions. We have cosine theta that was given to us. Sine theta that was equal to tangent theta. Cosecant Let's flip them over. Oops, sorry, secant. And that's it. Using the formulas from above. And the triangle, you'll be good.
You said secant would be 20, would it be 21 over 29 or is it 29 over 21?
Secant, I didn't flip it over, did I? Okay, yeah, any question number 8, I'm gonna move something else, because the next couple are the same, they just. The setup is a little different. Number 8 too, okay. Alright. Well, quickly, Brett, we won't solve these, but I'll go ahead and talk about them. So. Here they gave us X and Y, we had to find R in order to find these. Same thing for the last example we did, 5. The first example, 5. 6 is the same thing, 7 is more of a conceptual thing. We just did 8. Now number 9 is the same as 8, but they're giving you sine is equal to 0.8 in quadrant 2. So that means that cosine is either what? Is it positive or negative? What does that tell us?
Positive.
Quadrant 2.
Sorry, negative.
Yeah, X is
Negative, right? Because we're right here.
Yes.
So sine is plus. Cosine is negative. So that means this would be negative. This would be negative. This would be negative. This would be negative. Sine is given to us. So you can write 0.8 if you want to. This is my hint for you. As 8 over 10. That is the same thing. And then draw your triangle. You could reduce that. That would reduce to 4/5. So 4/5. Solve this missing side. And then once you have all 3 sides, you'll do the same thing here. Okay. But let's move on. 10 is the same thing, it's just to give you a different information. So here, change it to -6 over 1. And then figure out what quadrant you're in based on this information. If cosine is positive, but cotangent is negative, that means that the y is negative, so plus minus happens quadrant 4. So you kind of have to like figure out what quadrant you're in, and then decide which ones are plus or minus, and then build a triangle. Same thing over and over again. So 11 is something new. Find the reference angle of theta prime. I'm sorry, find the reference angle. So they're calling you the reference angle theta prime right here. Excuse me. So what does reference angle mean? it means the distance from wherever you landed to the x-axis. So given some angle theta, what is that? The distance to the x-axis. If I'm over here, sorry, this is theta, then let me close this. Sketch theta. Oh, here's negative 215. Okay. I didn't see they gave us an angle. So negative 215 means we're going in the negative direction. So there's going to be most likely this guy. But theta prime, having trouble denoting what they're talking about here. This is wrong. Here we go. This is the one. So this is negative 215. So once we land somewhere, the distance back to the x-axis is right here. So this is the reference angle for negative 215. Okay. So if I land out here, if I land out here, right, then the distance is the same thing. Like, let's say I had another problem. In this case, theta is equal to theta prime because it's quadrant 1. So the distance from the x-axis is the same as wherever I sweep across. Okay. But if I go out here, let's say I spin all the way out here and I stop somewhere right there, then now the distance would be from here to here. Let's say I stopped there or somewhere. This new distance would be reference. Okay. Does the definition of reference make sense? Just in case. What is the reference angle for 135? So I went all the way up to here. What's my reference angle? In other words, what's the distance from this angle to here?
$45.
45, right? Okay. So if I go from here to here, the distance back to the x-axis is the same. So here theta and theta prime are the same. Quadrant 2 is the distance to the 180. Now if I go down here, okay, well, how far is this from here to here? This would be reference. What is the reference angle of 210? That is this distance here. $30, yeah. So in the book, there's like a formula that tells you how to find each reference angle depending which quadrant you land in. But essentially, this is what you're doing. Okay. Does that make sense?
Yes.
Reference angle will never be negative because it's just distance. Let me see if I remember the formula. It's in the book, but reference angle. Number one. If theta is in quadrant one, then theta prime equals theta. Theta prime will denote reference angles. Number two, if theta is in quadrant two, then theta prime is equal to 180 degrees minus theta. If theta is in quadrant three, then the reference angle is equal to theta minus 180. Yeah. And I'm just making these up by looking at the circle, but they are legit and it is in the book. I'm just deriving them, I guess. If we're in quadrant four, it'll be 360 minus theta. Yes. So this is assuming they give you like a really weird angle, like, I don't know. Because it's easy to calculate if you have the circle and it's a basic angle, right? But let's say I gave you an angle of, I don't know, 140 degrees, right? Or 145.2. So you could use this to find that exact number, the exact reference angle. Is there any questions on reference angles? All right. Here they're saying use or find the sine, cosine, and tangent of negative 150. So basically figure out where is negative 150. If you go in the negative direction, 150 is right here going in the positive, right? So going in the negative would be here. 210, right? Yeah, 210. So just go and so all you got to do is plug in 210 into sine, cosine, and tangent, or use the values of x and y for x and y right here for sine, cosine, tangent, then you'll be good. That'll give you the solutions to this question. So finding an equivalent angle to the one in question is finding the coterminal angle. So you would say that negative 150 degrees is coterminal. To 210. So basically an equivalent angle is considered to be coterminal. So plug in this guy or use the values in the circle to get the exact, you need to get the exact answer, so don't use a calculator, use a circle. So if an angle is negative, another way to do it is just add 360, and that'll land you right on might be easier. Land you right on 210. So if it's negative, add 360, and you'll find the coterminal angle right away. If the angle is too big, subtract 360, or the equivalent, subtract 2 pi. That makes sense?
Yep.
Let me write it down just in case. If an angle is negative, add 360 to find the standard angle. Which is coterminal to the negative angle. If an angle is above 360, subtract 360, oops. Until you are below 360. And if it's in radians, we'll just do the same thing, but in radians. Right? Any questions on what you would do for 12 and 13? Just add 360, subtract 2 pi. Here you just plug it into your calculator. There's nothing to do for 14 and 15 and 16. Actually, all the way to 17, there's nothing to do here. 18, I'm gonna delete, so don't worry about this guy. Well, let me see. Is it super easy? Current amperes are 100 volt circuits. Oh yeah, you just plug it in. That's it. Yeah, there's nothing else to talk about here. 14 through 18 is just plugging into your calculator. 12 and 13 is using ideas of coterminal angles, reference angle question, and then solving for these sides. Okay. You guys have any questions or concern on the last few sections? Like, did you have any issues, or do you need any extensions? I don't know if anything's closed.
Can you extend 6.2?
Yeah, I don't mind doing that.
Yeah, I wrote to extend that one yesterday as well.
Okay.
So for question 13, 11 pi over 4, the coterminal would just be like 3 pi over 4 since we're just subtracting 2 pi.
Yeah, subtract 2 pi until you're below 2 pi. I believe that's the one, yeah.
Okay.
Okay, 2412. Let's reschedule. So it was 2, you said?
Yes.
All right, I'll go ahead and schedule 6162 and 63 for Monday next week. Okay. You get some extra time, but
Thank you.
don't try to stay ahead though. Don't assume I'm gonna keep doing it. But I don't mind helping you out.
And you said 6.3 is gonna be due Monday?
Yes.
Perfect. Cool.
So as soon as we talk about it, I try to give about usually when homework will be due on the Monday. After we talk about it. So currently I've only put due dates on stuff we've talked about. Okay. So as we go along, I'll be changing the due dates.
Okay. So would you go over today and on Wednesday? That will be for the homework for Monday?
Right.
Okay, cool.
But I think, let me see here.